Hey guys, Mr. Bowman here. We are carrying on with 1.2 Algebra, which is the MCAT. We're focusing on all the excellence questions from the 2018 exam. In this video, we're going to start off with question number 26 from the website. If you're not sure on the website links, just let me know in the comments if I haven't put them there and I can fire it your way. But question 26, we've got a right angled triangle and that's the area there, 35 centimeters squared. What is the value of x? And x relates to the height and the base of this triangle. So whenever I start off with these generic questions, I just write down the formula that I'll be using. Area is equal to 1/2 of base times height. Once you're at this stage, you start your substitution process. So we're going to take out the area, put in 35. So 35 is going to be equal to 1/2 times, we've got the base of the shape, which is 4x plus 6, and we've got the height of the shape over here as well. So that will be times x times 4x plus 6. We're going to go ahead and simplify what we can. What I'm going to do is I'm going to get rid of this this times 1/2 by doing times 2 times 2. So we've got 70 is equal to x bracket 4x plus 6. I'm now going to expand that bracket. So 70 is equal to 4x squared plus 6x. And we're going to go minus 70, and that's because quadratics always have to be equal to 0. So 0 is equal to 4x squared plus 6x minus 70. All of these terms are even numbers, which means they've got that 2 in common. So it'll be 2 bracket 2x squared plus 3x minus 35. And if I go divide by 2, that leaves me with 0 is equal to 2x squared plus 3x minus 35. At this stage here, that 2 is a bit irritating by the x squared, so it means we're going to have to use the grouping method of factorizing. So I'm going to start by multiplying that and that together. That gets me to negative 70. I now need to think what multiplies to the negative 70 and adds to that positive 3. And hopefully you're thinking positive 10 and negative 7. So I'm going to split up my 3x into 10x and negative 7x. So 0 is equal to 2x squared plus 10x minus 7x minus 35. And I'm going to factorize the groups. There's my first group, there's my second group. 0 is equal to 2x x plus 5. The next one, they've got a negative 7 in common, x plus 5. I like this method because it's self-checking. I've got the same bracket coming up twice, which means I've done it right. So 0 is equal to x plus 5. And then the leftovers, the 2x and the minus 7, they form to get that second bracket. 2x minus 7 equals, oh, there we go. So I've now factorized, so I can now come up with my two solutions. So first solution, if x plus 5 is equal to 0, this equation is true, so that relates to the first bracket. So here, x1 is equal to minus 5. We're then going to do the same for the second one. 2x minus 7 equals 0, so we're going to go 2x equals 7, x equals 7 over 2, and then x equals 3.5. We now need to think about our two answers. Are they both relevant? Quadratics sometimes spit up wrong answers, and that negative 5 definitely are wrong because that means this side of the triangle up here is negative 5, which doesn't make sense. So x can't equal negative 5 because triangles can't have negative dimensions. Have negative dimensions. And we can wrap up. Therefore, x is equal to 3.5 centimeters. So a fairly long question, a lot of work there, but we got to our answer in the end. So question 27, we've got Sophia and Tama. Their grandmother is a maths teacher. She bought them some fidget spinners. I'm glad they're gone, to be honest. They were a bit annoying. Tama thinks that she is older, that she should get more than Sophia. What that tells us is that T should be greater than S. And T would be the number of fidget spinners Tama gets. S would be the number of fidget spinners that Sophia gets. Blah, blah, blah. Each of them relates to the number of N, which is down below. their grandmother says that the fidget spinners will be n cubed plus 3 times this number, which can be written as this. So that relates to Sophia. Tama will get n squared plus, or times 2 plus another 6 times that n. So what that means is, so n squared times 2, so 2n squared plus 6 times the number. It's plus 6n. What value could n have so that Sophia gets more fidget spinners than Sophia? Geez, a messy question in the words, but let's get into it. Luckily, we've already got most of the expressions. So 2n squared plus 6n. When is that greater than? Because that relates to Tama, and Tama needs to be greater than Sophia, and that relates to Sophia's one, and I'll use n cubed plus 3n. n cubed plus 3n. So there's our inequality. We basically just have to go ahead and solve it. So it does look like it's going to be a quadratic inequality because you can see every part has an n in common. So we're going to divide everything by n to get rid of that. So divide by n, divide by n, divide by n, divide by n. That gets rid of that common factor. So we're going to be left with 2n plus 6. When is that greater than n squared plus 3? Let's do a bit of algebraic manipulation because it is a quadratic, so I need something one side to be 0. So we've got minus 2n, and then we're going to go minus 6, minus 6. So when is 0 greater than n squared minus 2n minus 3? At this stage here, remember you can't really solve quadratic inequations. You need to kind of graphically investigate it. So let's make that an equation to find the x-intercepts. So we've got n squared minus 2n minus 3. When we factorize that, that's going to be, we'll keep writing an x, but n minus 3, n plus 1, which means my two answers would be 3, or my two x-intercepts, n1 and negative 1. So sketching that as a parabola, there's my x and y axes. I'm sketching a graph. This here is negative 1. That there is positive 3. And that less than 0, from where we stopped our own equation, that tells us the portion of the parabola we're caring about. We care about when the parabola is less than 0 or below the x-axis. So we care about this area here. So we care that negative 1, n, and 3. So because this is contextual related, we can't have part of a fidget spinner, so we can't have 0.5, we can't have negative fidget spinners. So if you look at all your options, it's going to be negative 1, which it actually can't be. It could be 0 fidget spinners, 1 fidget spinner, 2 fidget spinners, or 3 fidget spinners. So it can't be 3 either. And we can't have 0 fidget spinners because if Tama has 0 fidget spinners, that means Sophia has to have less than that, which would be negative fidget spinners, which doesn't really make sense. So that's gone there, which means the only two values for n which can actually result in anything here would be 1 or 2. So therefore, n can be equal to 1 or 2. Now on to question number 28. These are my favorite type of questions. Simply, it says solve that. So let's jot down our equations. We've got 8 times 2 to the power of x minus 4. When is that less than 20? So I know this is going to be a bit irritating to do. The 20 isn't a base of 2. So that's going to be an issue we have to face later on. But 8 is a nice number because 8 is 2 to the power of 3. So let's put that in. So 2 to the power of 3 times 2 to the power of x minus 4. When is that less than 20? Let's simplify these. They've got the same base of 2, which means we can add the powers together. So 2x minus 4 plus 3. So you can see I've just added 3 to the power. That's what I meant by that. When is that less than 20? And then that is 2x minus 1. When is that less than 20? This step here, it's going to be a bit irritating. So that 20 needs to go. We need to explore the numbers that are 2 to the power of something. So 2 to the power of 1 is 2. 2 squared is 4. 2 cubed is 8. We used that earlier on in this question. 2 to the power of 4 is 16, and 2 to the power of 5 is 32. And the reason I stop here is I've got a number more than 20, which is the number we've got here. So that means our 20 would sit somewhere in between 16 and 32. The only issue you have here is you need to think about which of these do you use? Are you going to use 2 to the power of 4? Or are you going to use 2 to the power of 5? And it doesn't really matter which way around you do it, but I'm going to use 2 to the power of 4, which means, so 2x minus 1, when is that greater than or equal to 16? Because 16 is less than 20, which means the number itself is an answer, which is why we need the equal part of it. If you didn't use the 16, maybe use the 32, you would have had to do less than 32 without the equal sign, because we don't want to include 32 as part of our answer. But we're going to use the 16 here. We're now going to change 16 to 2 to the power of 4 to get the same bases. So x minus 1, 2 to the power of 4. The bases cancel, as I said. So x minus 1, when is that less than or equal to 4? We're going to go plus 1, x is greater than or no less than or equal to 5. And what that means is our answers, x could be equal to 5, 4, 3, 2, and so on. Anything down below there. So nice questions. As I said, they're my favorite ones, but I do get that they're a bit irritating. Question number 29, back to a wordy question. So we've got George and Leo organizing 27 people in 2 groups to a sports game. The cost per ticket, $20 for $20 for a student, $30 for an adult. We'll need that later. Half of George's group are students. 2/3 of Leo's group are students. And the natural conclusion is 1/2 of this group is adults. And 1/3 of this group are adults, because they can only be students or adults. The cost of 27 tickets was $650. How many students are in Leo's group? So a bit of a weird question. What we're going to do is we're going to start off with just defining our variables. So what we're going to do is we're going to let S equal number of students. And this part's really important, both groups. We'll get to Leo and George's groups later on. And we're now going to let A equal the number of students, or number of adults rather, in both groups as well. And the reason we have to start with the combined 27 is because some of the information we've been given, particularly the ones down the bottom and the top there, they relate to the total groups, not the individual groups. So we can then work with the individual stuff later on. So I'm going to start off by doing, I know that adults plus students is equal to 27. And I also know that 20S, that relates to the $20 for each student, plus 30A, that's the $30 per adult. I know they combine down the bottom there to get $650. I've got some simultaneous equations here, so I'm going to use my skills to calculate S and A. What I'm going to do here is I'm going to start off with by doing, well, let's make A the subject over here, so minus S minus S. So A is equal to 27 minus S. And I can now substitute that in for this A over here on the right-hand equation. So we've got 20S plus 30 bracket 27 minus S equals 650. The maths here is going to get fairly messy, particularly when we expand that bracket, but we've got 20S plus we need 20 times, or 30 times 27. Don't forget in MCAT, no calculators, so feel free to use your old school division. But 7 times 30 is 210, and then we've got 20 times 30 is 600. They combine to get 810. So that's going to be 810 minus 30S equals 650. We're going to go minus 810 minus 810, get rid of the numbers. So that means that negative 10S will be equal to 160. Negative 160, actually, get rid of the negatives because they cancel each other out. So 10S equals 160, which means S is equal to 16 students. The adults will be really easy to calculate because the adults is equal to 27 minus S, which is 27 minus 16. We just calculated S, so we're going to substitute it in, which means the number of adults equals 11. We're going to get a bit messy. So thinking of this 1/2, 2/3, 1/3 type nonsense, we now need to form some more equations. So we know the number of students combined was equal to 16. And these 16 students comprised of 1/2 of George's group. So we're going to let G equal the number of people in George's group, and that came from up here. And 2/3 of Leo's group. So that's going to be plus 2/3 of Leo's group, L representing Leo's group. I then need to do the same for adults. So 11, the number of adults, will be equal to, and we've got them up here, it's going to be 1/2 of George's group plus 1, or the other 1/3 of Leo's group. And we've got another simultaneous equation to solve. So I'm actually going to subtract them. So that's equation number 1, that's equation number 2. This here will be equation number 1 minus equation number 2. So we've got 5 is equal to, the G's cancel each other out, 1/3 of L. And we're going to go times 3, which means L is equal to 15. So what that means is there were 15 people in Leo's group, and Leo's group is what we're interested in. But we're only interested in the number of students in Leo's group. And don't forget, we were told that 2/3 of Leo's group are students. So carrying on from this L, so 15 times 2/3, because 2/3 of Leo's group are students, as I mentioned, is equal to 10, which means there are 10 students in Leo's group. Therefore, there are 10 students in Leo's group. So certainly one of the more complicated, one of the more messier excellence questions I've seen in the lead up to making all these videos. Lots of simultaneous equations to get us to our final answer of 10. On to question number 30. Georgia is designing a new logo for a sports club, and it's made of 2 circles, and there are the 2 circles. She draws one circle on top of another circle, just like we're seeing there. The total height of the 2 circles is always 20 centimeters. Georgia is exploring what happens to the total circumference of the 2 circles when the radius of one circle increases and the other decreases. So what that means is, what will the circumference of the circles be? So let's say that one we make it bigger, this one here makes it smaller. What will the circumference, or the combined circumference of the circles, end up being like? Show that the 2 circumferences of the circle is 20 pi centimeters. So the word show means they've given you the answer, which is 20 pi. You need to go ahead and get to that answer. So that's what they mean by show. So I'm going to start by defining my variables. And my variables comprise of 2 things here. So I'm going to write R with a little s. That there is going to be the radius of the small circle. Radius of the small circle. And I'm going to define the big circle, RB, the radius of the big circle. So they're my 2 things. You might have used different letters. You could have used like X and Y, whatever, but I'm just going to stick with RS and RB. So I'm now going to start thinking about the relationships I have, and I know that RS, the radius of the small circle, plus the radius of the big circle, should be equal to 10 centimeters. And I just want to note here, I think a lot of people would have written 20 centimeters from the question, but just a reminder, that 20 comprises of the 2 diameters added together. So half of that 20 will be the 2 radiuses, which is why we go from 20 to 10. And thinking of the next relationship, the total circumference, TC, that's going to be equal to the 2 individual circumferences added together. So it's going to be 2 pi times the small radius. That'll be the circumference of the small circle. And we're going to go plus 2 pi the radius of the big circle. Those added together will give you the circumference of the total logo. I'm now going to do minus RB. So RS will be equal to 10 minus RB. And the reason I'm doing that is I want to substitute in RS over here, and that will leave RB, or the big radius, as the only variable in that expression. So I'll show you what I mean. So this RS is going away, and I'm putting in 10 minus RB in its place. So we've got 2 pi bracket 10 minus RB plus 2 pi RB. and you can see RB is the only variable left, and that's kind of what we're aiming for. The only issue is, as I said, it's a show question, 20 pi is the answer, so I also need to think of a way, or how am I going to get rid of RB, because I can't have any variables here for this question. What I'm thinking is, because one is positive and one is negative, I'm hoping if I just expand and simplify, they cancel each other out. But if they don't, I'll have to come up with another strategy. So let's see what happens. So this times this, that's going to be 20 pi. That times that, so that's going to be minus 2 pi RB plus 2 pi RB. And I really like that. As I said before, I was hoping they cancel out, and we can see we've got a minus and a plus, so these cancel each other out, leaving 20 pi as our solution. So we've shown that the circumference of the circles, the total circumference, will always be equal to 20 pi. Question 31, and I just want to note that carries on from the previous question, so I've got the same definition of variables, RS and RB, from the previous one. We've been asked to give the equation for the difference of the areas of the two circles. Your answer should be in its simplest form. So, going to be a bit messy, I think, here. Let's start off with what we did know from the previous question, was we knew that RS plus RB was equal to 10, and we got to RS being equal to 10 minus RB. We now need to think about the difference in areas. So I'm going to call it difference of areas. That's going to be equal to the area of the big circle minus the area of the small circle. So that's going to be pi r big circle squared minus pi r small circle squared. So we're subtracting the big circle from the small circle to find the total difference. And what I also know is I know RS in terms of RB. So I'm going to substitute that in to here. So carrying on, that's going to be equal to pi RB squared minus pi, and then we've got our brackets, 10 minus RB squared. Now, this is going to be a bit messy. This is here, it relates to our quadratics. It's a perfect square, so I'm going to have to write it out as a double bracket. So that's going to be equal to pi RB squared minus pi times 10 minus RB, and the same bracket coming up twice. So we've got that there. I'm now going to expand my bracket. When I expand that, I'm just going to move a bit over for some extra room for working. We've got pi RB squared minus pi, and in our bracket we've got 100 minus 20 RB plus RB squared, close bracket, and I'm going to expand this here to get that pi everywhere as well. So that there is going to be equal to pi RB squared minus 100 pi plus 20 pi RB, and then finally we're going to go minus pi RB squared. Geez, getting really messy, but we're getting there at the end. The pi RB squareds, one is positive, one is negative, they cancel each other out, leaving us with 20 pi RB minus 100 pi. I have switched them around to make sure the positive expression is at the beginning. Over here, there's not much more I can do, actually. There's some common factors, so potentially I could factorize, so that there would be 20 pi, and then that's the radius of the big circle minus 5. But I think if you got to either of these answers here, those there would be the expressions or the equations, because don't forget we've got the difference of the areas. On to question number 32, one of my favorite type of questions, and that's simply just find x. So we've got 5 times 5 to the power of 3x. When is that equal to 5 to the power of negative 2x squared? So I think it's an x squared, so I know it's going to be a quadratic eventually. And I'm seeing lots of 5s as the base number. So my first step is I'm looking to simplify the 5s and the base numbers to a quadratic. And then once I've got a quadratic, I'm looking to solve or factorize and solve that quadratic. So I guess the next step is there's an invisible 1 by that 5, which makes adding these two powers together to get a single base of 5 a lot easier. So that's going to be 5 to the power of 3x plus 1. When is that equal to? 5 to the power of negative 2x squared. The base numbers cancel each other out, leaving me with 3x plus 1. When is that equal to negative 2x squared? It's a quadratic, so I need to make it equal to 0. So I'm going to go plus 2x squared to both sides. So I've got 2x squared plus 3x plus 1 equals 0. So I've got my simplified quadratic. I now need to go ahead and factorize and solve. I'm using the grouping method here because of that annoying 2. So I need to think 2 times 1 is 2. What multiplies to this 2 and adds to that 3? And you're thinking 2 and 1 as well. They add to 3, multiply to 2. So I'm going to break my 3x into 2x and 1x. So I'll show you what I mean by that. 2x squared plus 2x plus x plus 1. When is that equal to 0? And this 2x plus x, that comes to the 3x from the line above. So I haven't actually changed the equation. I've just made it look a little bit different. I now factorize the groups. There's my first group. There's my second group. So I've got, they have a 2x in common, leaving me with an x plus 1. These one here, they don't really have in common factor, but I always pull out a common factor of 1 because everything has a common factor of 1. So I'm going to go plus 1, and then my second bracket, 3 or x plus 1. When is that equal to 0? Let's form the bracket. So my common bracket was x plus 1. So that's these two brackets. And the leftover bits, 2x plus 1, they form that second bracket. So we've got 2x plus 1 over here. When is it equal to 0? I can now find my two answers. So the first bracket, x plus 1 equals 0, minus 1 minus 1. So the first answer for x is equal to negative 1. And the next one, 2x plus 1 is equal to 0. So 2x equals minus 1. The second answer of x is equal to negative 1/2. So there are my two answers. There's no context, which means there's not really going to be any false answers to think about eliminating. So I think that's where I'm ending up. So that wraps up all the excellence questions from the 2018 exam. Hopefully you found this video really, really useful. Keep an eye on the 2019-2020 exams that are going to be coming up pretty soon.